In this video, I am explaining exercise 6.5 of class 10, that is triangles chapter. So exercise 6.5, let us see the first question. So class 10, chapter triangles, exercise 6.5 from NCERT textbook. First question, sides of a triangle are given below. Determine which of them are right triangles. In case of a right triangle, write the length of the hypotenuse. So these are the measurements of each side: 7 centimeter, 24 centimeter, 25 centimeter. So let us see the solution. For a given length to be the sides of a right triangle, they must satisfy the Pythagoras theorem, which states hypotenuse square is equal to base square plus perpendicular square. So if you see this is a right angle triangle. So the base is this is the perpendicular, and this is the hypotenuse. Okay. So that means this being the longest side, so the largest of the three numbers should be taken as the hypotenuse, and the other two has for base and perpendicular. So if you take the first case, so we see that in a right triangle, the hypotenuse is the longest side. So you should take the longest side under the hypotenuse, first case. So in this, 7, 24, 25, 25 is the longest length. Therefore, this should be the hypotenuse, and this can be taken as base and perpendicular. So it is 25 square is equal to 7 square plus 24 square. 25 square is 625, 7 square is 49, and 24 square is 576. If you add these two, it becomes 625 is equal to both are equal. That means either side is equal. Since Pythagoras theorem is satisfied, 7 centimeter, 24 centimeter, 25 centimeters are the sides of a right triangle. And the length of its hypotenuse is 25 centimeters. Now the second bit. 3, 8, 6. 8 is the longest, so hypotenuse is equal to base square plus perpendicular square. So longest side is 8, so this should be the hypotenuse. So take it, 8 square is equal to 3 square plus 6 square. 64 is equal to 3 square is 9, 6 square is 6 exactly 36. Add these two, you are getting 45, which is not equal to 64. So since Pythagoras theorem is not satisfied, 3, 8 and 6 are not the sides of a right triangle. Next, 50, 80, 100. Use the same conditions. Hypotenuse square is equal to base square plus perpendicular square. 100 square is equal to 50 square plus 80 square. 100 square is 100 into 100 is 10,000. 50 square is 50 into 50 is 2,500. 80 square is 80 into 80. How do you do this? 8 square, 8 8 is 64. 1 square is there, 1 0 is there, so double the number of zeros. So you will be able, so 5 square is 25. Only 1 0, double the number of zeros. Your 1 square is 1, 2 zeros are there, double the number of zeros. That's how you can write the squares. You need not multiply. Now, if you add these two, if you see here, you are getting 8,900, which is not equal to 10,000. So since Pythagoras theorem is not satisfied, 50 centimeter, 80 centimeter, 100 centimeters are not the sides of a right triangle. Fourth bit, 13, 12, and 5. So hypotenuse square. So 13 square is equal to 12 square plus 5 square. 13 square is 169, 12 square is 144, and 5 square is 25. To add, you're getting 169 is equal to 169. Since Pythagoras theorem is satisfied, 13, 12, and 5 are the sides of a right triangle. And the length of the hypotenuse is 13 centimeters. Question 2. PQR is a triangle, right angled at. So now you have to prove that this is PQR is a triangle, right angled at P, and M is the point on QR, such that PM is perpendicular to QR. We have to show that PM square is equal to QM into MR. See the solution. Let's draw the figure first. This is a right angled triangle. Okay, P, it's a right angled at P, so we write P here. Then we write Q, and here R. Okay, it's a right angle, so 90 degrees here. This is 90. Now, QR, PM is perpendicular to QR. QR is here. We have to draw from P on M, perpendicular. So let us draw this perpendicular. Name it as M. And this is 90 degrees. Okay. So PM is perpendicular to QR. Now, in triangle PMQ, PMQ, this bottom triangle. So in this triangle, 90 degrees is here. So this is the hypotenuse. So you are using the Pythagoras theorem. So PQ square will be PQ square is equal to PM square plus QM square. Okay, let us number it as first equation. Now take the triangle PMR. PMR. In this triangle, this is the hypotenuse. So PR square is equal to PM square plus MR square. Number it second equation. Now in triangle PQR, that means you're taking the full big triangle. QR is the hypotenuse. So let us write it as QR square is equal to PQ square plus PR square. This is the third equation. Now, how did we get all these three? Using Pythagoras theorem. So, all these three by using Pythagoras theorem. That is the theorem. Now, substituting equation 1 and 2 in 3. We substitute. This is PQ. So, this value we will substitute here. This value we will substitute here. So, QR square is equal to PM square plus QM square, because this is PQ. So PQ means PM square plus QM square plus PR. PR is PM square plus MR square. Okay. Now QR. QR is QM plus MR. So let us write this as QM plus MR. QM plus MR whole square is equal to PM square plus QM square plus PM square plus MR square. Here we use A plus B whole square identity. So how did you get QM? So if you see this figure, it is QR is QM plus MR. So that's what I've substituted here. Now we are going to use a identity A plus B whole square. A square plus B square plus 2AB plus this PM square plus QM square plus PM square plus MR square. Now, so how we are done? A plus B whole square is equal to A square plus B square plus 2AB. Now, if you see here, QM is here. So this cancels with this. MR cancels with MR. So what is left here? We are left only with these two terms. So here this and here PM and PM. PM plus PM is 2PM. So 2QM into MR is equal to 2PM. Here 2 cancels with this 2. Therefore, QM into MR is equal to PM square. Think clear. Next, question number 3. In the given figure, ABD is a triangle right angled at A. AC is perpendicular to BD. Show that these three cases are there. Now let us see the thing. Let us first draw the figure. This is a triangle right angled at A. That means this is the right angle here. So we should take A here. This should be B and this will be C. D. For ABD is a triangle. AC perpendicular to BD. BD is here. So from A, one perpendicular should come. So this is a 90 degrees here. So perpendicular from A. This is C. AC is perpendicular to BD. This is also 90 degrees. Now, first condition, that is for the first case, in triangle ABC and ABD. ABC, this means this triangle, and ABD, this complete big triangle. In these two triangles, take this small triangle and this complete triangle. You see here, ACB, that is this angle, is equal to angle BAD, is this angle. Both are 90. Why? It is given. Okay, it is given that they are perpendicular. Then angle B, this particular angle is common to this side triangle and it's common to the full big triangle also. It's a common angle. So since these two triangles are having two angles equal, therefore triangle ABC, that is this triangle, small triangle, and this big triangle, both are similar by AA similarity. So since these two triangles are similar, the ratio of the sides must be equal. So since the triangles are similar, the ratio of the sides are equal. Now, angle B. So what is the angle B means? What is the side hypotenuse upon the adjacent side? So this angle, we are taking the hypotenuse upon the adjacent, that is AB upon BC. And it is also equal to the full triangle. Therefore, when you talk about the full triangle, the hypotenuse is BD upon the base length AB. So it is AB upon BC is equal to BD upon AB. Cross multiply AB into AB will be AB square. So you'll get AB square is equal to BC into BD. So this was your first condition which has been proved. Now let's go for the second part. Second one, in triangle ACD. ACD, we are taking this triangle. Okay. And so in this triangle, ACD, this triangle, this is a triangle. So you should know that sum of the angles of a triangle is 180 degrees. So ACD plus CAD plus ADC is equal to 180 degrees. Sum of the angles of a triangle is 180. So this angle is 90 here because we know this is 90. So let's write 90 here. 90 plus CAD plus ADC is equal to 180. Take 90 to the right side. It becomes 180 minus 90. So CAD, this angle and this angle. So if you number this, I am preferring to use it as number so that it's easy to understand. So this angle and second angle is here. That is ADC. This is one angle. That means angle 1 and angle 2 together is 90. So you can write angle 1 plus angle 2 is 180 minus 90 is 90. Let us take this as the first equation. Okay. Now, in triangle ABD, take the complete triangle. In this complete triangle, again, let's use the angle sum property. If you take angle sum property, so it is BAD, that is this angle, which is 90, plus ADB, plus angle ABD. This complete is equal to 180. Again, sum of the angles of a triangle is 180. So let us write this as 90 because this is 90 here. Put it 90. 90 plus this 2 is now take 90 towards the right. It becomes angle ADB plus angle ABD is equal to 180 minus 90, which is 90. So that means ADB. ADB is this second angle and ABD, this B angle. So I'll write number this also. Number it as 3. So now it will what will happen? It is angle 2 plus angle 3 is 90. Let us call it as second equation. So this is also 90. This is also 90. So that means angle 1 plus 2 must be equal to 2 plus 3. So if you take this condition, this is your figure. So you get angle 1 plus 2 is 90, which was the first condition. Angle 2 plus 3 is also 90, which is the second condition. So that means both are 90. That means these two must be equal. So angle 1 plus angle 2 is equal to angle 2 plus angle 3. So angle 2 is on either side. So it cancels. This 2 cancel. Angle 1 is equal to angle 3. That means this angle is also equal to this angle. Now, so that is the third. Now let us take in triangle ACD. ACD, that means this triangle, and ACB, that is this triangle. So these two triangles, what are you getting? angle ACD, this angle is equal to angle ACB. These two are 90 degrees. Go perpendicular. And angle 1 is equal to angle 3, which this is given. Angle 1 is equal to angle 3 from this condition. Proved above in 3. Therefore, since these two angles are equal, these two triangles must be similar. So triangle ACD is similar to triangle ACB by AA similarity criteria. Because these two triangles are similar, so the ratio of the sides must be equal. So it is now angle 1 and angle 3 are equal. Okay. So angle 1. So take the side in front of it. Angle 1 in front of it is CD upon adjacent side AC. Opposite upon adjacent. And angle 3 opposite. Okay. Angle in front of 90 degrees. Okay. Now you see AC upon BC. Opposite. Angle 1 is equal, see, angle 1, opposite side is CD and adjacent side is AC. And when you take angle 3, opposite side is AC and adjacent side is BC. So AC square is equal to BC into DC. AC square is equal to BC into DC. This was your second condition. Now let's take the third case. ACD and ABD. ACD, that is this triangle, and ABD, that means the complete triangle. In this angle is equal to this angle ACD, that is 90 degrees, is equal to BAD. Both are 90. It is given. Next, angle D is common to both these triangles. This angle is part of this triangle and it's a part of the bigger triangle also. So it's a common angle. So therefore, these two triangles, that is this small triangle and the complete triangle, both are similar by a criteria of similarity. Because these two triangles are similar, the ratio of the sides must be equal. Therefore, AD, okay, in this triangle, 90 degrees is here. The opposite is AD upon the adjacent. And in this triangle, when you say D, opposite is ABD upon hypotenuse upon AD, adjacent. Hypotenuse, so when you took triangle, this small triangle, it is hypotenuse upon adjacent. When you take the big triangle, hypotenuse is BD upon adjacent is AD. So AD into AD will be AD square is equal to BD into CD. This was the third question. Clear? 3 bits proved. Now go to the fourth question. Question number 4. ABC is an isosceles triangle right angled at C. Or to prove that AB square is equal to twice AC square. Solution. First draw the triangle. What it says ABC is an isosceles triangle. Isosceles right triangle at C. Isosceles triangle means two of its sides are equal. So this is a right angle triangle. So this side is the longest side, it cannot be equal. So these two must be equal. It says right angled at C. That means this point is C. So name it. This is a right angle. So that means this should be C. The other part will be A. This will be B. Now it's an isosceles triangle. So this side is the longest side. It cannot be equal. So these two must be equal. So that is this side is equal to this side. These two sides are equal. Is it? Now what is given? Angle C is 90 degrees and AC is equal to BC. AC is equal to BC. It is given and angle C is 90. This is what is given. So from here we say, to apply Pythagoras theorem here, this is the hypotenuse. So hypotenuse square is equal to sum of the other squares. AB square is equal to AC square plus BC square. Now we want it in terms of AC, and AC is also equal to BC. So that means I'm going to change BC, not AC. So I'll write it as, this was by Pythagoras theorem. So AC is equal to BC. So what I'll do, AB square is equal to AC square plus AC square. Because we want it in terms of AC, so let us change AC. Had it been in terms of BC, we should have changed this. AC square plus AC square is 2AC square. So AB square is equal to 2AC square. So your thing is proved now. Question number 5. Again, ABC is an isosceles triangle. AC is equal to BC. And if AB square is equal to twice AC square, prove that it's a right angle triangle. Figure is same type. This will be the figure. It is the same as the previous one. Two sides, that is AC and BC, are equal, and angle C is 90 degrees. To prove that ABC is a right triangle. Now, what is given here? This is given. AB square is equal to AC square. 2AC square can be written as AC square plus, this is given. So you can write it as AC square plus AC square. But what it is, AC is also equal to BC. So let me change one. AC is also equal to BC. Therefore, AC square plus BC square. So what I am getting, AC square plus BC square is equal to AB square. This is nothing but Pythagoras theorem. This is Pythagoras theorem. Therefore, by converse of Pythagoras theorem, triangle ABC must be a right triangle. Because if the Pythagoras theorem is being satisfied, it is possible only for a right triangle. That means the given figure is a right angle triangle. Sixth question. ABC is an equilateral triangle of side 2A. Find each of its altitude. So, triangle ABC is equilateral. So, let us draw equilateral. This is an equilateral triangle. When you say equilateral triangle, all sides are equal. Okay. So, let's name it first. A, B, C. Each side is 2A, it is given. That means this side is 2A. Let us mark it. ABC is an equilateral triangle of side 2A. So let us mark it as 2A. This is 2A. This side should also be 2A. And this side also should be 2A. All three sides are of the same length. Clear? Now, AD is the altitude. That is, AD is perpendicular to BC. Altitude means from here there should be a perpendicular. That is, okay, perpendicular drawn. So this is perpendicular, and here this is D. AD is a perpendicular. That means this angle is 90 degrees. Now what we do is, now D is a perpendicular, from A to D is a perpendicular. So D now is here in triangle. We take this triangle, that is ADB and ADC. In these two triangles, angle ADB is equal to ADC, both are 90 each. Then, because AD is perpendicular, both are 90. Then, AB, this side is equal to this side. AB is equal to AC is equal to 2A. It is given because it's a side of a right triangle. Sorry, sides of a equilateral triangle. This is given. And AD is common. This one is common to both. So, because these two are, this angle is 90, these two sides are equal, and this is common to both. Therefore, the common side, therefore, these two triangles are congruent. Congruent. So, they are congruent by right angle, hypotenuse, side rule. RHS congruency. So, R means right angle, H means hypotenuse, S is any one of the sides. Okay, so it is RHS congruency. Because these two triangles are congruent, that means BD and DC must be equal. BD and DC must be equal, but BC is 2A. So that means this should be A, this should be A. So this is A. So why it is? We got the congruent parts of congruent triangle. That means this is A and this is also A. Clear? Both are A, because A plus A is 2A. That is the total length of the side. Now triangle ADB is a right triangle. So we use Pythagoras ADB. To this triangle we use Pythagoras theorem. When you use Pythagoras theorem, it is AB. AB is the hypotenuse. So AD square plus BD square is equal to AB square. Now let's what is AD? AD is H. BD is A. And this is 2A. So let's put the values. H square plus A square is equal to A square. So 2A square is 4A square. And plus A when it comes inside minus A. So 4A square minus 1A square is 3A square. H square is 3A square. Take the square root of both sides. It will become H is equal to square root of 3A square. That is A comes outside the root sign. It becomes A root 3. H is A root 3. Yeah, so that is the height of the triangle. So find the height here said. So height is all the altitude is A root 3. In an equilateral triangle, all the altitudes are of the same length. So each altitude is of length A root 3. So because you can draw an altitude from here also, you can draw an altitude from here also, they all will have the same length. So you need not prove all the 3 bits again and again. Let's understand. Question 7. Seventh question. Prove that the sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. Now, let us draw a rhombus. This is a rhombus. Let's draw the diagonal A, B, C, D. This is a rhombus. A, B, C, D is a rhombus. Let's draw a diagonal. AC is a diagonal. BD is another diagonal. So we have got the 2 diagonals. Now we make use of a property of this rhombus. What is the property? Using the property of a rhombus that diagonals of a rhombus are perpendicular bisectors of each other. Diagonals, that means these two are perpendicular bisectors of each other. That means this angle here is 90. Clear? So, and bisector means BO and OD must be equal. OA and OC also must be equal. Therefore, we get OA and OC are equal. If both are equal, that means OA and OC must be half of AC. Similarly, BO and OD are equal. That means BO and OD both must be equal to half of BD. And AC and BD are perpendicular to each other. So they are perpendicular bisectors. So these two are perpendicular, and so these are the conditions which you get. Now let's apply Pythagoras theorem to each of these triangles. 1, 2, 3, 4. 4 triangles we have got. Let's apply Pythagoras. So therefore, triangle AOB, BOC, COD, and AOD are all right triangles. Because all are right triangles, we apply Pythagoras theorem. Applying Pythagoras theorem to all these triangles, we get, first I take AOB. AOB, this triangle. AO square plus OB square is equal to AB square. AO, what is AO? AO is half AC. I can write this. OB is half BD. So let me write that. Half AC square plus half BD square is equal to AB square. You take the square of this number, it becomes 1 by 4 AC square plus 1 by 4 BD square is equal to AB square. LCM is 4. 4 is common, so take common 4 and take it to the right. It becomes AC square plus BD square is equal to 4AB square. Number this as first equation. Okay. Similarly, if you do for the other triangles, you'll get, see, similarly for triangle AC, you take BC square is this triangle. BC square also will be AC square plus BD square is equal to 4 BC square. So it will be a second. You will again get AC square plus BD is equal to 4 CD square. This will be a third. And again, AC square plus BD square will be equal to 4 AD square. This will be a fourth equation. Now, if you see these four equations, AC square, AC square, AC square, BD square, BD square, BD square, BD square, 4AB square, 4BC square, 4CD square, 4. So let us add on all the four. Adding 1, 2, 3, and 4, we get 4, because all are 4 times, therefore 4, AB square plus BC square plus CD square plus AD square. We got 4 common from all these three. And here 4 AC square plus 4 BD square. So 4 taken out common. 4 cancels. 4 cancels and you get AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square. The sum of the squares of the sides of a triangle is equal to sum of the squares of its diagonals. Eighth question. In the figure, O is a point in the interior of a triangle. OD perpendicular to BC. So we'll see the first figure. Let us see how the figure will look. This is the figure which is given. This figure is given in the triangle. Right? So he says that O is a point in the interior of the triangle. So O is a point inside the triangle ABC. OD is perpendicular to BC. OE is perpendicular to AC. And OF is perpendicular to AB. Okay. We have to prove these two conditions. So in triangle, in the given figure, OD perpendicular to BC, OE perpendicular to AC, and OF perpendicular to AB. Now, join OA. Let us join O and A. Let us join it. Join. Then let us join OB. Then, and we have to join OC also. Let's join OC. OC join. Now, in triangle AOF, I'm taking this triangle. In this triangle, this is the right angle here, so this is the hypotenuse. So OA square is equal to AF square plus OF square. Clear? And now you take in triangle BOD. BOD, this triangle. OB square is the hypotenuse. So OB square is equal to OBD square plus OD square. How we are going about is, see here, we want to prove this. So OA we got, so I am writing in terms of OA, OB and OC. So that means I have to take, and so next what is that? In triangle OCOE, COE, I have taken this triangle. Right angle is here, so this is your hypotenuse. So OC square is equal to CE square plus OE square. Okay? So this is the first, second, third. First, second, third. How we have got all these three results? Adding all these three we have got by using Pythagoras theorem. Because then add 1, 2, and 3. Let us add all the three. OA square plus OB square plus OC square is equal to this square plus this plus this. You'll get the whole thing with this. Okay. Equal to AF square plus OF square, BD square plus OD square plus CE square plus OE square. Now, what you if you see this answer, how we want OD, OE minus minus minus. So that means if you take OD, OE, and OF to this side, you will get your result OE, OA square, OB square, OC square minus OD minus OE minus OF is equal to AF, BD, and CE. This is your first condition. So your first condition proved. Clear? That's it. It is just using Pythagoras theorem to all the three triangles and go ahead. And just add them, you get the answer. Second, now let's rearrange the terms to get the second answer. Rearranging it, see how we have wanted AF square. Okay, AF, BD, CE, AF, BD, CE. These three is already there. So we need not touch this part. We are interested in AE. AE, where is AE? AE is here. If this is AE, then AO minus OE will give you AE. So let us see. I'll just show you how it is. Now, what I do, see this first. In triangle, I'm going to take, in this here, what I have done, COE I have taken. I have taken COE. Now, I'm not going to take this triangle, I'm going to take this triangle. AOE. In AOE, OA square is equal to AE square plus OE square. Now, let me take this OE this side. It will become AO square minus OE square is equal to AE square. Yeah. Now, second, BOF. BOF, this triangle. Here, OB square is equal to OBF square plus OF square. Take OF this side. OF square minus OB square minus OF square is equal to BF square. Third triangle, COD. COD, this triangle. Again, this is the hypotenuse. So OC square is equal to CD square plus OD square. Take OD this side, you'll get this. So if you see here, AE we want. AE we want here. So AE is what? OA minus OE. So here in this what I do? OA, here there's OE, I bring it near it, minus sign. I just change the position. It's on the left side itself, so the sign does not change. It's still on the left side of the equal to sign, therefore the sign will not change, it just changes its position. So OA square minus OE square. OB. Now we want CD. CD is what? BF, sorry. BF is OB minus OF. OB minus OF. Bring them together. And OC minus OD. Bring them together. So if you see this, OA square minus OE square. OA square minus OE square is AE square. So this is your AE square. This is your BF square. And this is your CD square. So you'll get AE square plus BF square plus CD square is equal to this as it is. This proves your second condition. So just using Pythagoras theorem and little jugglery here and there, you're getting the answer. Next. Question 9. A ladder 10 meter long reaches a window 8 meters above the ground. Find the distance of the foot of the ladder from the base. See, ladder, that means it's like this. This is your ladder. This is the wall. The window is here, 8 meters above the ground. This is a window. Okay, this is the wall, and this is the ground level. 8 meters above the ground level, there is a window. A ladder is placed in this. So here, the length of the ladder is given 10 meters, and this distance of the window from the ground is 8 meters. You have to find the distance of the foot of the ladder from the wall, base of the wall. This distance you have to find. So this being a right angle triangle, we use Pythagoras theorem right away. So in triangle, AC square is equal to AB square plus BC square. So put the values 10 square. This is by Pythagoras theorem. So put the values 10 square is equal to 8 square plus x square. 10 square is 100, 8 square is 64 plus x square. Take 64 this side, it becomes 100 minus 64 is equal to x square. 36 is equal to x square. Take the square root of both the sides. X is equal to root 36, which is 6 meters. That means the distance of the foot of the ladder from the base of the wall is 6 meters. 10th question. A similar type, a wire attached to a vertical pole of height 18 meters. Pole is 18 meters and the wire length is 24 meters long and has a stake attached to the other end. That means you have a pole. So let us see how it is. This is a pole It is 18 meters long. There's a wire which is 24 meters long. It is a stake, means it is grounded here at this point with a nail. Okay, driven. So how far the base of the pole should the stake be driven so that the wire will be taut? Taut means it is not sagging, it is perfectly stiff and straight. So without any sagging is taut. Okay. Now, so this is a straight wire, no bend, no sagging. Again, it's a right triangle. So using Pythagoras theorem, AC square is equal to AB square plus BC square. AC is 24, put the value. BC, AB is equal to 18 and C. So 24 square is equal to 18 square plus x square. 24 square is 576. 18 square is 324 plus x square. Subtract it. 576 minus 324 is x square. So 252 is x square. So x will be root of 252, which is approximately 15.87 meters. That means this length, x length, is 15.87, almost 16 meters. 11th. Aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. At the same time, another aeroplane leaves the same airport and flies due west. It goes in the western direction at a rate speed of 1200 kilometers per hour. How far will be the two planes after 1.5 hours? This 1.5 hours is important. Okay, see this. This is a right triangle because aeroplane, it's a starting point. This is the airport. B is the airport. It goes north direction. It's going at a speed of 1000 kilometers per hour. Another plane starts at the same time from here and moves in the western direction. It is going at a speed of 1200 kilometers per hour. Okay, or CL. So that means when you use Pythagoras theorem, AC square is equal to AB square. Now he wants you to find the distance between the two planes after 1.5 hours. That means he wants to find the length of AC. Now you see this is Pythagoras theorem. We have found this. Now you see here, he is traveling at a speed of 1000 kilometers for 1.5 hours. So for 1 hour, that means 1000 kilometers per hour means in 1 hour he will cover 1000 kilometers. But here he got 1.5 hours, and in another half an hour he will cover another 500. So 1000 plus 500 will be 1500. That means the distance the plane which is traveling towards the northern direction would have traveled 1500 kilometers in 1.5 hours, and the plane which is going towards the western direction, so it is 1200 into 1.5, that is 1200 plus 600, that is 1800. So it has traveled 1800 kilometers towards the western direction, and the first plane has traveled 1500 kilometers towards the northern direction. So now let's put these two values here. X square is equal to 1500 square plus 1800 square, which is 2 lakhs, 22 lakhs 50,000, and this is 32 lakhs 40,000. Okay, how do you do this? 15 square. 15 square is 225. Two zeros are there, put 4 zeros. 18 square is 324. Two zeros are there, double the number of zeros. That's how you will have to think. Don't multiply. It becomes easy for you to do the squares. When you add these two, you'll get 549 and 4 zeros. That is 54 lakhs 90,000. Take the square root of this. So when you take, so 549 can be written as 9 into 61 and 10,000. So 3 square root of 9 is 3. Square root of 10,000 is 100. So 3 into 100, 300 and root 61. This is the distance between the two planes. That is distance between A and C after 1.5 hours. Question 12. Two poles of height 6 meters and 11 meters stand on a plain ground. If the distance between the feet of the pole is 12 meters, find the distance between their tops. Now there are two poles, vertical poles. Okay, so this is the pole. This is 6 meters. One pole. There's another pole which is 11 meters. 11 meters. Okay, they are on the plain ground. This is a plain ground. Okay, distance between the two plain grounds is 12 meters. That means DE length is 12 meters. Okay, AB and AE and BE. AE and BE are the two poles of length there. Distance between the poles DE is 12 meters. Draw BC parallel to DE. From here, we'll draw a line parallel to DE and join AB, and then we'll join A and B. So let us draw parallel. This will become parallel to DE, and let us name this as C. And this is we have joined AB, and let us name this as C here. Now, if this is 6 meters, this should also be 6 meters because this is the distance between parallel lines. So this will be 6. But the total length is 11. So that means the remaining length should be 11 minus 6, which is 5. 5 meters. Okay. So now what you have found, we have to find the distance between the tops. That means distance, the top of these two poles. This is the top of the small pole and A is the top of the bigger pole. So you have to find this distance. So because it is, we have drawn them parallel and this is perpendicular. So this is also a right angle triangle. So this is 12 and this is parallel. So this is also 12. Apply Pythagoras theorem to this triangle ABC. And apply Pythagoras theorem, it is AB square is equal to BC square plus AC square. Apply. So put the values. 12 square plus 5 square is 144 plus 25, 169. AB is equal to root 169, which is 13 meters. The length of AB, that is the distance between the top of the two poles, is 13 meters. Question 13. D and E are the points on side CA and CB respectively of triangle ABC, right angled at C. To prove that AE square plus BD square is equal to AB square plus DE square. So let us see. This is a right angle triangle, right angled at C. Okay, right triangle. It's a right triangle, right angle. So C is a right angle, and this is ABC is a triangle. Now D and E are the points on CA. D is a point on CA. CA is here, so that there is a point D here. Then E is a point on CB. CB is here, so there is a point D here. E here. Okay. Now, you see what he wants us to do. Find DE is there, AB is there, AE is there, and BD is also there. AE, AE, that means we should join this. BD, we should join this also. Then DE, this also should be joined. So let us join all the three. DE joined, join AE, join BD. Now you got all the three joined. Now let us apply Pythagoras theorem to each of the right triangles because all the triangles are right angle triangles. So in triangle ABC, ABC, the complete triangle I'm taking. AB is the hypotenuse. So AB square is equal to BC square plus AC square. First condition. Next, DE. DE is here. So this is the hypotenuse because right angle is here. So DE square is equal to DC square plus CE square. DE is equal to DC square plus CE square. This is your second equation. Next, take triangle AEC. AEC. So if you take AEC, AE is the hypotenuse. So AE square should be equal to AC square plus CE square. This is your third equation. Okay. Now, in triangle BCD, BCD, you are taking this triangle. Here, right angle is here. So BD is a hypotenuse. So BD square is equal to DC square plus BC square. This is the fourth equation. Okay. Now, what you should do? All these things we are using finding Pythagoras theorem. All are using Pythagoras theorem. We have written this four relations. Now, add third and fourth. Let us add only 3 and 4. When you add 3 and 4, you get AE square plus BD square is equal to AC plus CE plus BD, DC plus BC. Okay, I just added the thing. Now you see AC plus BC, AC square plus BC square, nothing but AB square, AC square plus BC square is AB square. So let us bring these two together, arrange it, rearranging the terms. That's all. AC square plus BC square, and take these two terms together. This is DC square plus CE square. So if you see here, AC square plus BC square, AC square plus BC square is AB square. DC plus CE, DC plus CE is D. Let's put that value. It will become AB square plus DE square. That's what we have proved. 14th question. Perpendicular from A on side BC of triangle ABC intersects BC at D such that DB is equal to 3CD as shown in the figure. Prove that 2AB square is equal to 2AC square plus BC square. So let's first draw the figure. This is a triangle. ABC is a triangle. Okay. And perpendicular from A on the side BC of a triangle. From A to side BC, we are drawing a perpendicular intersecting BC at D. He says that DB is 3 times CD. Okay, I have to prove this. Now let's apply Pythagoras and all our right triangles. So this entire exercise is based on right triangles. So Pythagoras theorem, time and again we are using the same thing. So in triangle ADB, that is this side triangle, this is the hypotenuse. So AB square is equal to AD square plus BD square. Now let us take this side triangle. Here this is the hypotenuse, AD square plus CD square. Yeah. Now this is the first one, this is the second equation. Now let us subtract the two. Both we are getting by Pythagoras theorem. So subtracting 1 and 2, what do you get? AB square minus AC square is equal to AD square plus DB square minus AD square plus CD square. Open the brackets. When you open the bracket, it becomes minus AD square minus CD square. AD square minus AD square should cancel. So this cancels with this. What are you left with? Only these two. Let us write it down. So AB square minus AC square is equal to DB square minus CD square. DB. DB. This is DB. What is DB? DB is 3CD. So let's put it here. DB is 3CD. Let's put here 3CD whole square minus CD. 3 square is 9. So it is 9 CD square minus CD square. 9 minus 1 is 8. So it is 8 CD square. AB square minus AC square is equal to 8 CD square. Now if you see our relation, we want 2AB square, 2AC square. Here there is only 1. So let us multiply the whole equation with 2. When I multiply the whole equation with 2, it becomes 2AB square minus 2AC square is equal to 16 CD square. 16 CD square. Now if you see here, I'll just see the figure. I'll just see BC. What is BC? BC is equal to CD plus BD. So BC is equal to CD plus DB. CD and DB is 3CD. So that means CD plus 3CD is 4CD. 4CD is equal to BC. Okay. So here what I do, I just write it in the slightly different way. 16 CD square can be written as 4 CD whole square, because 4 square is 16 and CD square is CD square. So now CD, 4 CD is BC. So let me put BC here. It becomes BC square. So AB square minus 2AC square is equal to BC square. We want it in this form. So let us shift this minus 2AC into the right. It becomes 2AB square is equal to 2AC square plus BC square. This is what we have to prove. 15th question. In an equilateral triangle ABC, D is a point on the side BC such that BD is 1/3 BC. And to prove that 9AD square is equal to 7AB square. See, this is how the figure is. It's an equilateral triangle. So let us draw an equilateral A, B, C. It's an equilateral triangle. ABC is an equilateral triangle. D is a point. D is a point on the side BC. That means on this side there is a point DC. Okay, such that BD is 1/3 of BC. So let us draw a perpendicular. Name it this perpendicular. Both sides are 90 degrees. This is 90, this is 90. Name it as E. Now from here I have to take D here. This is BD. Okay, BD is 1/3 BC. This is how you are figuring. Now, in triangle ADE, that is this small triangle, AD is the hypotenuse, so AD square is equal to AE square plus DE square. AE square plus DE square. This is by Pythagoras theorem. Now, AE is equal to, I can take DE to the left. So it becomes AD square minus DE square. Let this be the first equation. Now, take triangle ADE, AB, sorry, ADB this. In ADB, AB square is equal to AE square plus BE square. Take again BE to the left, becomes AE square is equal to AB square minus BE square, and number this as second equation. Now if you see this, the two equations, this is also AE square, this is also AE square, that means these two should be equal. Let's equate the two. Equating 1 and 2, what you'll get? AD square plus minus DE square is equal to AB square minus BE square, both are equal. Now, let's see. That means AD square minus AB square is equal to DE square minus, this is positive, I bring it to the right side, so DE minus BE. Okay, we want everything in terms of AD and AB only. So I have retained AD and AB on this side and brought the remaining things on the left side, right side. Okay. Now see here, in triangle AEB and AEC, that means AEB, that means this right triangle full and this full right triangle. This angle is equal to this is equal to 90. AEB is equal to AEC is equal to 90 degrees. And because it is perpendicular, AE is perpendicular to BC, that's why it is 90. AB is equal to AC. Why? It is an equilateral triangle. So it is equal. Sides of an equilateral triangle, they are equal. And AE, this side is common to both these triangles. It's a common side. Therefore, triangle AEB and triangle AEC are both congruent. They are congruent by RHS congruency. That is right angle, hypotenuse and side congruency. So these two triangles are congruent. That means here this triangle and this triangle both are congruent. So what you can say, BE and CE must be equal. Because the triangles are congruent, the sides must be equal. Why? because they are the congruent parts of congruent triangle. Usually you can write it as CPCT. It is understood and it's accepted by the board also. You can do that. And now this that means BE and CE are equal. Now let us write BC. What is BC? BC is equal to BE plus CE. So I can write CE also has BE. So it will become BE plus BE. That is 2BE. That means BC is half BE. BE is half BC. Okay. That's number. This is the fourth equation. This is your third equation. Now, this is your figure. BE is equal to 1/3 BC. 1 by 2 BC. This is your fourth condition. And we have got the BE is equal to BD plus DE. So BE is what? 1 by 2 BC. BE is equal to 1 by 2 BC and BD is equal to 1 by 3 BC and DE. Let us take this one this side. It becomes DE is equal to half BC minus 1 by 3 BC. Let's take LCM here. To take LCM, BC you take it out common, 1 by 2 minus 1 by 3. So LCM is 6. So it will be 3 minus 2 upon 6. So this is DE is 1 by 6 BC. Let us name it as fifth equation. Now what was the condition we got? AD square minus AB square is equal to DE square minus BE square. This was from your third equation. So now let's put BE as 1 by 2 BC and DE will put it as 1 by 6 BC. Substitute here, substituting the values of DE and BE from 4 and 5, we'll get 1 by 6 BC square minus 1 by 2 BC square. Well, BE is 1 by 2 and DE is 1 by 6. Take the square of it. It will become 1 by 36 BC square minus 1 by 4 BC square. 36 and 4. LCM is 36. So that means this should be multiplied. This second thing should be multiplied with 9 to make it 36. So it will be 1 minus 9 upon 36 BC square. So 1 minus 9 will be minus 8 upon 36. So AD square minus AB square is equal to minus 8 upon 36 BC square. But BC is also equal to AB because it's the side of a right equilateral triangle. So, but BC is also equal to AB. So I can change this to AB. I can write it minus 2 upon 9 AB square. Now here you got AB and here also you got AB. So let us take this minus AB. If you take it this side, it becomes plus AB square minus 2 upon 9 AB square. Taking LCM again. So this is AB upon 180. So 9 is LCM. So that implies 9 minus 2 upon 9 AB square. 9 minus 2 means AD square equals 7 upon 9 AB square. Take 9 to the left, sorry. It becomes 9 AD square is equal to 7 AB square. I'll go through this question once more so that you will understand it more clearly. Next question, 16th question. In an equilateral triangle, prove that three sides of a square of one side is equal to 4 times the square of its altitude. 3 times the square of one side is 4 times. So what it is? ABC is an equilateral triangle, it is given, and AE is an altitude. That means it is AE is perpendicular to BC. So in triangle AEB, that is this triangle, applying Pythagoras theorem here, AB square is equal to AE square plus BE square. Okay, this is the first equation by Pythagoras theorem. So in triangle AEB and AEC, AEB and AEC in these two triangles, AEB and AEC both are 90 here, and because it is perpendicular, AB is equal to AC because they are the sides of an equilateral triangle, and AE is equal to AE, it's a common side. Therefore, these two triangles, that is, this triangle and this triangle, both are congruent by RHS congruency, that is right angle, hypotenuse and side congruency. Because these two triangles are congruent, you can say BE is equal to EC. BE and EC are equal. Therefore, because they are the congruent parts of congruent triangle. You can write it as CPCT. Therefore, BC, if you see this figure, BC is equal, this full BC is equal to BE plus EC. BE plus EC. So that means you can write, because BE is also equal to EC. So EC can be changed to BE. So you get BE plus BE. It is BC is equal to twice BC. B. That means BE is half of BC. Clear? That is your second condition. So BE is half BC. Now, AB is in the triangle. See, this is ABE. AE is equal to half AB square is equal to AE square plus BE square. And BE is equal to half BC. This is the second condition. Now, substituting this in the second one. Second condition in the first one, if you see here, AB square is equal to AE square plus half BE square. Square of 2. 1 square is 1, 2 square is 4, BC square. Now BC is the side of an equilateral triangle, which is also equal to AB. So I can replace this as, take this and first that side, AB square minus 1 by 4, BC square as well. But BC is also equal to AB. So I write it as AB square. Take LCM. 4 minus 1 upon 4, AB square is equal to AE square. That is 3 upon 4, AB square is equal to AE square. Take 4 this side. It becomes 3AB square is equal to 4AE square. That means 3 times the square of the side of an equilateral triangle is equal to 4 times the square of the altitude. Yeah, this is the proof. 17th question, the last question. Tick the correct answer and justify if in triangle ABC, AB is 6 root 3 centimeter, AC is 12 centimeter, and BC is 6 centimeter. The angle B is, see here, what is given? AB is given. So write down that AB. Now, if it has to be at right angle, so let us see if it is, take the square of it. AB square is equal to 6 root 3 square. 6 square is 36, root 3 square is 3. 36 into 3 is 108. Now let's take AC, 12. 12 AC square will be 12 square 144. Next take BC. BC square is 6 square is 36. Now if you see here, you are getting 108 plus 36 equal to 144, which is equal to AC square. Therefore, since AB square plus BC square is equal to AC square, it is a triangle ABC is a right angle triangle. Right angle at B. Therefore, angle B is 90 degrees. So your answer should be option C. So your answer is option C. Yeah, that is the thing. So if you have understood it, please don't forget to click on the subscribe button and also click on the share button and share with your friends and see that, so that you subscribe for it, so that you'll get further more notifications from all the things.